IT developed Kerberos to make it easy for administrators to manage passwords by storing them centrally, enhance security by ensuring no clear text passwords are transmitted, and allowing users to access different services with the same password. Having passwords in a central location will obviously make them easier to administer. But how do our services authenticate users when they don't know the user's passwords? Why don't we just limit ourselves to using protocols that encrypt the passwords? That's safe, right? Well, yes, encryption is a good way of protecting our authentication. But even if the password is encrypted, chances are the poacher can decrypt it pretty easily using free tools from the internet. So what we need is a way to keep passwords off the network in the first place. And that's exactly what Kerberos does. Let's take a look at how Kerberos protects your passwords by keeping them off the network, and at the same time makes management easier by centralizing the storage of the passwords. To begin with, the name Kerberos gives a clue to the way Kerberos works. In Greek mythology, Kerberos was the vicious three-headed dog that guarded the gates of Hades. In network authentication, Kerberos creates a realm with 3 players that collectively guard your network: the Kerberos client, the Kerberized service, and the Key Distribution Center, or KDC. We'll see how these 3 players work together to provide secure authentication with all the passwords stored in a single location and not transmit clear text passwords during the authentication process. And from the user point of view, access to each service is transparent. In fact, the user can access all the services by logging in only once. Users and services in a Kerberos realm are known as principals, and each has its own secret encryption key stored on the KDC. The system administrator creates these keys, and they are shared only by the principal and the KDC. Each principal trusts that a packet encrypted with this key must come from the KDC. The KDC also has a private key that it shares with no one. This key ensures the integrity of the authentication process. Here's how it works. We'll use blue for the user's key, red for the services key, and green for the KDC's key. It's easy to see that the KDC can encrypt a packet with the user's key and then have the user decrypt it with the same key. The trick is getting encrypted sessions between the user and the services. Remember, they don't have any permanent shared keys. Well, how does the KDC do it? The critical piece to remember is that each principal trusts that anything encrypted with its private key comes from the KDC. So if the user can present the service with a packet encrypted with the service's private key, the service knows that this user was authenticated by the KDC and can be trusted. Let's take a look at how the whole process works, beginning with the initial logon. It's morning, and our user has just logged into his computer and entered his username and password into the login screen. The packet traveling to the KDC contains the user's name, but does not contain the password. That's the security problem we're trying to solve. This packet is a request for a ticket-granting ticket, or TGT. You need a valid ticket to access a resource because it proves your identity. The user principal will eventually use this TGT to receive tickets for all of the services it wants to access, and the person sitting at the computer will never see it happen. As part of the security in Kerberos, tickets do expire, so they're always time-stamped. The KDC looks in its user principal database and confirms that this user is indeed a valid user. The KDC then creates the ticket-granting ticket. This contains the user's name, the KDC name, the client's IP address, and a new key called a session key. The session key is a time-sensitive encryption key that the KDC generates just for this session. We have to change those session keys periodically in case an intruder captures our packets and tries to decrypt our encryption key. Then all of this information is encrypted using the KDC's private key, so the client never actually sees the contents of the TGT. The KDC then sends back a packet containing two things: the ticket-granting ticket and another copy of the session key, which is encrypted with the user's private key. The client uses its private key based on the password that the user typed in when he sat down this morning to log in to open the service key. So what's the point of sending the client a TGT when the client is unable to read its contents? Well, watch what the client does when it wants to request a service. The client first creates an authenticator. This includes the client's name, the IP address of his computer, and the time. It encrypts the authenticator with the session key it just received from the KDC. Then it creates a packet that contains the still unopened TGT, the authenticator, and the name of the requested service, and sends this packet to the KDC. When the KDC receives this packet, it can decrypt the TGT, and knowing that it can't have been falsified because it hasn't been opened, the KDC uses the TGT to check the information in the authenticator. Now that the KDC is ready to trust the identity of the user, the KDC can send a service ticket to the client. The service ticket is particular to the requested service and only works for this user for a set period of time. The service ticket includes the user name, the service name, the IP address from the client computer, and a new session key. Then the KDC encrypts this ticket with the service's private key. Note that the client does not have the service's private key and cannot modify the contents of this ticket. The KDC places a copy of the new session key and the service ticket into a packet and encrypts the whole thing with the first session key it shared with the user, and the KDC sends this back to the client. The client decrypts the packet and uses the new session key to encrypt a new authenticator and sends it to the service. The service uses its private key to open the service ticket and is guaranteed that the ticket came from the KDC because no one else has that key. Then it uses the new session key it finds there to open the authenticator. The service uses the information in the service ticket to verify the information in the authenticator. Now that it has verified the identity of the user, the service sends back an acknowledgement and the user is authenticated. Thanks to Kerberos, we just solved 3 problems. We have more secure authentication, simplified management of passwords, and the convenience of single sign-on.